In this video, we'll be proving this theorem, that if I have a subspace of an inner product space, I can look at projections on W, and if I have an orthogonal basis, so a basis of perpendicular vector, then the formula is just a generalization of what we had for projection on vectors in Euclidean space. I'll have the inner product with all the basis vectors divided by the norm squared times v. Alright, so we're going to prove this. I'm going to start by the fact that we know, so by the projection theorem, U equals projection on W plus projection on W perp. And I'm going to call this one, let's call it W, little w. This one is X. And so what we know is W's in big W and X is in W perp. Alright, so W is what I'm after. I want a formula for W. Since W's in W, by the theorem that we actually proved a bit earlier, let me give you the theorem numbers because we've seen a bunch. Theorem 12.2. I have an element of a vector space. I have an orthogonal basis for that vector space, W. So we know that W equals WV1 inner product V1 squared times V1 plus WVK VK squared VK. Alright, so by theorem 12.2 we already know how to decompose the vector W in terms of a basis for the subspace W. And so now all I have to talk about is the fact that we don't want to use W, we want to use U. So I need to make sure that these inner products are the same as those. So whether I have W or U here, both would work. Of course, if I knew W, there would be no need for projections and no need for this formula. So this formula is a bit useless in these circumstances. This is perfect because I know U and I know the basis. So this one I can use, that one over there is not that helpful at this moment. Alright, but if I take U dot some random element of the basis, well, we said U was W plus X. Now my inner product is nice and linear, so I can split it over the sum. So W VI plus X VI. This is fine, that's what we want. Now here, I have X which is in W perp, and I have VI which is in W. So I know they're perpendicular because they're in perpendicular spaces. So here X is in W perp, VI is in W, and so this would be 0. So this inner product is 0, and I get plus 0, so let's not write it. Alright, so I end up, let me put it a bit higher so I can conclude on this board. This is 0. Alright, so this formula for W then give us, alright, so this projection is W, and I can now replace W dot VI with U dot VI, so I'm going to get U V1, length of V1 squared, U VK length of VK squared.